All right, so we're looking at a triangular based pyramid, and so we're given some information here. So if you zoom in on this and see what we've got, you can see that we have the triangular base right here. You can see a couple of pieces. You can see that this is a right triangle and our pieces are 3 centimeters and 5 centimeters. And then we have a right triangle drawn from the bottom to the tippity top of this triangle, or the pyramid. And so what we're trying to do is figure out the volume of this. So when you have something like this, either it's a pyramid or if it's a cone, when you're finding the area of the base of it, in this case it's a triangle, the triangular shape is not the same size as you get to higher and higher. So the area is getting smaller and smaller as you get to the tippity top of this. So what happens is, because this is a third of the shape of what it originally would start at, if those are the dimensions given to you, you're basically like shaving it off to what you have to get that point. So when you're looking at something like these types of shapes, we're going to divide it by 3 or take a third of the size of it. So what I have here is just what your typical volume would be. They were giving it to you in like Google. You might see base times height divided by 3 or base times height times a third. So you need to take a look at the base, and the base is a triangle in this case. So depending upon the pyramid's base area, you would figure out the area of that base, and in this case, because it's a triangle, the triangle's area is base times height divided by 2, or half of its base times height. And then once you figure that calculation out, you're going to then take a look at the height of this pyramid. And the pyramid height, if you look back to this, it needs to be from the center of it all the way to the tippity top of it, because you need the right angle here. You want to make sure that it's the highest height possible, because anywhere else has to be a slant height. So it's not as high except from the dead center to the tippity top of it. So we need to make sure that it's the height of the pyramid, and then we can take that information and we're going to divide it by 3. So what I'm going to start off with is the base of the triangle, which was a 3 by 5. So we're going to take 3 times 5. We're going to divide that by 2. And then we're going to take the height that we were given in this problem, which is 6 centimeters. And then once we do that, we're going to divide this by 3 to get our answer, and just show you on the calculator so you can see it. It's a lot of calculator work, a lot of this volume stuff. 3 times 5, again, most of this you can just do in your head. 3 times 5 equals 15 divided by 2. I just want to point out, when you have decimals, do not touch those decimals until the very end of your answer. We're going to times it by 6, get 45, and then we're going to divide it as our last step by 3, which should be pretty easy. These are easy numbers. And you get 15. So our volume on this one is a volume of 15, and we are doing centimeters, so it is centimeters, and then the answer would be in cubic dimensions, so 15 cubic centimeters. If you want more questions like this, you can find them on my YouTube channel, You Want Algebra. Check them out under the volume section.